Today I am solving the problem of overhanging beam. Downward arrow is positive, upward is negative. Positive, sagging, hogging will be negative. Negative for clock, anti-clock, clockwise negative, anti-clock positive. Positive. I will convert into a point load here. Convert into point load. A load is acting, RA upward, reaction will be RB, and this is C, exactly at the center, 60 into 6, it is 360 kilonewton, and 3 meter this side, 3 meter this side, 2 meter, sorry 2 meter not, the value is 60 into 2, 120 kilonewton, 1 meter this side, 1 meter this side, the couple acting here, 210 kilonewton meter. Now we have to find out the reaction. Therefore vertical force is equal to 0, RA minus RA plus 360 minus RB plus 120 is equal to 0. Take minus common, RA plus RB, bring this two terms this side, it becomes minus 480 kilonewton. This and this cancel. RA plus RB is nothing but 480 kilonewton. Equation 1. Now taking moment about A, taking moment about A, we have to take the moment about A here. Now as you take the moment about A, the couple comes in picture here. You have to consider that couple here. Okay. Now first minus 120 into distance, that is 6 into 7. Next plus RB into 6 minus 360 into 3, and the couple you have to consider. That is plus 210 is equal to 0. This is a very important problem. Okay, couple you have to consider here. Now if you substitute, the RB value will be 285 kilonewton, and put this value in equation 1. Put RB in equation 1. RA is equal to 195 kilonewton. 195 kilonewton. Now go for shear force. Shear force value. Now SF at C, there is no load, directly 0. There is a load at the bottom. SF at B, right side, it is 120 kilonewton. SF at B, left side, 120 minus RB value is 285. Answer is 165 kilonewton. Now similarly at A, the shear force, the couple doesn't have effect on the shear force. At A, right side minus 165 plus 360, the answer is 195. Here already 195 is there. RB is 285 kilonewton. SF at A on left side means this side, left side, 195, and the bottom will be 195 is equal to 0. Draw the shear force diagram here. A will be 0, 195, 165 minus 165, 120 and 0. positive, negative, positive. As the line cuts from negative to positive, the maximum shear occurs at when the shear force is 0. We have to find out the x distance here. Let us go for bending moment. We'll go for bending moment. First, at A, as it is A, there is a couple. First write couple, left side, bending moment at A, left side you have to consider the couple, and left side you have to consider the couple. If you multiply, the value will be 0. Let us go for solution. Minus 120 into 7 plus 285 into 6 minus 360 into 3 plus 210 is equal to 0. Now go for right side. BM at A, right side. That means you have completed left side, now it is right side. Minus 120 into 7, just neglect 210 here, plus 285 into 6 minus 360 into 3. The answer is minus 210 kilonewton meter. Now bending moment at B. This is A, this is B. The bending moment at B. B will be minus 120 into 1. That is minus 120 kilonewton meter. Bending moment at C will be 0. Draw the bending moment now here. Draw the bending moment. First is 0, last is 0. Now we have to find out the maximum here. Maximum we have to find out. How to find out maximum? This is an x. Rewrite here. Rewrite here. Rewrite the part here. It is a inclined line, complete inclined line. Notice it is a straight line. 195. This is x, and distance will be 6 minus x. 6 minus x, and this will be 165. Now x divided by 195 is equal to 6 minus x divided by 165. With the help of the calculator you can find out the x value. Alpha x divided by 195 is equal to 6 minus alpha x divided by 165. Shift solve is equal to x is equal to 3.25 meter. The value is 3.25 meter. Now find out the maximum. First you have to find out the area into previous value. What is the area here? Area will be 1 by 2 into 195 into 3.25. 1 divided by 2, 2 into 195 into 3.25. Now it is 367 plus, that means 316.875. 875 maximum. Now at the couple there are two values, A 0, one more A 210, that means 210 will be here, kilonewton meter. The maximum we have found it. Next is at B, it is 120 kilonewton, and this is 0. That means because of UDL it will be parabola in this way. And there is a straight line here. No, there is a parabola because UDL is there. Negative, negative, positive, positive, and negative. Now we have to find out the point of contraflexure. These points we have to find out. How to find this point? Now I will cut this part in order to find out the x distance. By using this part you can find out the distance of this also. Now I will rewrite this part again. I will rewrite here. UDL is there. This is the bottom RB, RB value is 285 kilonewton, and I have to convert into a point load. This value is 60 kilonewton meter, and this distance will be 2 meter, and this is unknown X. I will convert into a point load here. (285) RB. Here its value will be 60 into 2. This is 120 kilonewton. 1 meter this side, 1 meter this side, and here the value will be 60 X. X by 2 this side, X by 2 this side. You have to find out G, and total length will be X here. We have taken X here. Now moment about G or G value. Bending moment you have to take. Now first 120 minus 120 into distance, that is 1 plus X. 1 plus X. Next plus 285 X minus 60 X into X by 2. 60 X divided by X by 2 into X by 60 X into X by 2 is equal to 0. Is equal to 0. Further calculate this part. Minus 120 minus 120 X plus 285 X and 30 X square is equal to 0. Minus 30 X square and this plus 165 X minus 120 is equal to 0. With the help of calculator you can find out the values. 5 square term 3 minus 120, sorry, minus 30, 165 minus 120. The values are, X values are 4.637, one more 0.862. Select the smaller value. Select smaller value. This value also comes in use, smaller value. That means the value of this part is X is 0.862. Now the value of X is nothing but here 0.862. If you measure the distance from this part to this part, is nothing but total length is nothing but 6 meter. The total length will be 6 meter here. The total is 6 meter. Now you can deduct this part in order to obtain 6 minus 0.862. The obtained value will be 5.138 meter. Now we have to find out this part. We got the one more value here, 4 point. We got the value. You have to deduct with this value. 6 minus 4.637. You will get value 1.36 meter. These are the point of contraflexure. These are the point of contraflexure. We call it the point of contraflexure here. Point of contraflexure. These are the point of contraflexure. These are the point of contraflexure. In this way you have to solve the problem. I have taken the half portion. I found the two values. The first value, I will select the smaller value. This is the X here. I will deduct from the total length. Then you will get the point of contraflexure from this direction. Okay, if you want to take this from this direction, that is 2 plus 0.826, you will get the point of contraflexure from this direction. Whatever this value has to be deducted from this part. 4.6 minus this part, you will get the value of this. Is a point of contraflexure.